Hello, my name is Caitlin Miley, and today I'll be introducing the work of myself and my co-authors on when, where, and how to add neurons to artificial neural networks. In conventional deep learning, architectural improvement requires costly hand engineering and reusing architectures known to work well on general tasks. We can instead use structural learning, which is the optimization of both the architecture and its parameters. Considering the operations we can perform on the graph structure of a network, pruning from a neural network is well studied and has a well-defined search space of entities to prune, like in this example of neural pruning. On the other hand, trying to add new entities has an infinite search space, even if we only consider widening existing layers with new neurons. In order to tackle this larger search space, we break neurogenesis down into the following considerations: when, how many, where, and how. We can answer these first three questions with the trigger strategy for each layer at each step, outputting the number of neurons to add, whether it's 0 or more than 0. Then we can use an initialization strategy for each new neuron triggered. To design a neurogenesis strategy, there are three main sources of information available: activations, weights, and gradients, including an additional auxiliary gradient that intuitively represents the potential gradient if neurons from alternating layers were connected. Beginning with activations and weights, we propose to add neurons while the effective rank is relatively high, as there may be useful neurons not yet present within that layer. When orthogonality is low and thus redundancy is high, we pause neurogenesis and instead continue with just weight updates until orthogonality increases again. This defines our trigger for activation and weight-based strategies. As for a gradient-based trigger, the largest potential gradient norms of new neurons are the singular values of the auxiliary gradient matrix. So we compare these to the gradient norm of the existing neurons to define our gradient-based trigger. Here we summarize the strategies that we will compare empirically. Our North Star strategies based on neuro-orthogonality consists of activation and weight-based strategies. The previous works of GradMax, Firefly, and Nest are re-implemented initializations with our framework and paired with the gradient-based trigger. Please come see our post to refer to our paper for results and further details. Thank you for your attention.